Good afternoon, good morning, everyone. Today, we are going to present Oasis platform for climate change catastrophic risk assessment in Asia. My name is AKM Saiful Islam. I am working as a professor at the Institute of Water and Flood Management in Bangladesh University of Engineering and Technology. And this presentation actually is on using cyclone and storm surge risk modeling through the Oasis platform for Bangladesh. And along with me, my other colleagues, Naharuma Mehjabin, Dr. Mohan Kumar Das, Farooq Abdullah, and Maruf Billah also work in this project. This is a project supported by loss modeling framework. There are several partners, Postdom Institute for Climate Impact Risk, there are also Met Office Hadley Center UK, also IUCN Bangladesh working in this project. And this is, as I mentioned earlier, funded by Federal Ministry for the Environment, Natural Conservation and Nuclear Safety of Germany. And this project is a 2 year project where we see how the cyclone and storm surge risk in formed in the Bay of Bengal is going to actually impact Bangladesh. So this modeling framework of Oasis Hub is used in this project. Now I'm going to have a look at the outline of my presentation. We have several natural disasters observed in Bangladesh. As you know, the climate change is impacted the natural disaster around the world, and it will impact more in the future. We have a number of cyclones in the past, which has Cyclone Amphan in 2020, Cyclone Bulbul in 2019, Cyclone Fani in 2019, Cyclone Mora in 2017, Cyclone Roanu in 2016, and also Cyclone Ayla in 2009, and Siror in Cyclone in 2007. So you can see from these figures that recent years, the cyclone occurring frequency is more, and it actually more frequent cyclone is occur. This year, the super cyclone actually formed in the Bay of Bengal in the month of May, and its landfall on 20th May. I will also take a look on the impact of tropical cyclone and possible future changes that is expected from various studies. We'll show how we do the storm surge inundation modeling and how we transfer this risk into using the depth damage relationship under the Oasis loss modeling framework we are using to disseminate this information online. And today, actually, when we are presenting, there was a cyclone formed in the Bay of Bengal, which is a low pressure system, not cyclone. It's a favorable temperature was 29 to 30 degrees and good moisture supply and partial Mediterranean oscillation support that could aid to well-marked low pressure system into the deep depression in Bay of Bengal, which could have a speed of 40 kilometers per hour and radius of 50 kilometers. So this season, which is called post-monsoon season in Bangladesh, which cyclone forming favorable season of this part of the area. And this season, we have seen devastating cyclone occur. So we have to have a look, take a look of this month, actually up to November, that how cyclone is formed or any impact the coastal area of Bangladesh. So government is prepared for this month. Now I'm going to take a look of the super cyclone that I already mentioned occurred in 16 to 21 May 2020, where we have seen that maximum sustained wind speed was 240 kilometers per hour. And this speed actually, when it occur, we call it super cyclone after 220 kilometers per hour. And the pressure was 920 hectopascal. There are a number of fatalities, like 128 people died, 26 in Bangladesh, and damage was more than 30.6 billion, out of which 1.5 billion in Bangladesh, and maximum storm surge height was 3 to 4 meters. And its path was its landfall West Bengal, India, close to the Bangladesh border. So Bangladesh was a bit lucky that it directly did not landfall at Bangladesh. As you know, Bangladesh is very flat terrain, 0 to 5 meter in coastal area. So, and the highest number of densely populated country. So it could have more damage if it is landfall directly to Bangladesh. This is the track that I'm talking about. It landfall in West Bengal, and it then later reduces the speed and landfall in Bangladesh. And this is a storm surge height over Bangladesh. This is Bangladesh, and here you can see this is Sundarban region. This is mangrove forest, and the surge height maximum was up to 3 meter. So it was protected wind and surge by the Sundarban, which is one of the reasons that damage and fatality is less compared to India. If I take a look at the recent cyclones occur in the Bay of Bengal, Cyclone Amphan occurred in 2020. As I mentioned, there are several other cyclone, Bulbul, Cyclone Foni last years, and then Cyclone Mora, Ruanu, Ayla, and Cedar. In before Cedar was a Category 5 cyclone. There was a cyclone occur in 1991, which has a wind speed maximum 235 kilometer per hour. This is a super cyclone when the death was 138,000 people was died. And in Bola cyclone 1970, which is the maximum wind speed 185 kilometer per hour, but death was 500,000 people died in this cyclone. You can see the fatality is reduced. Now the same super cyclone, we have 26 people died because of the huge coastal program, volunteer by volunteer and building cyclone shelter, disaster preparedness program taken by in the coastal region by Bangladesh government and NGOs and others helping. So the disaster fatality is reduced. We are a kind of role model in South Asia to reduce the disaster risk. But on the other hand, damage is not reduced. You can see still $1.5 billion US dollar damage under this cyclone. So why this cyclone and storm surge occur in Bay of Bengal region almost every year? Because the sea surface temperature is during pre-monsoon and post-monsoon season play a big role, which is around 25 to 27 degree or above. It is a favorable condition now, and we see the more warmer than Arabian Sea and relatively lower vertical wind shear and additional influx moisture come from South China Sea. All makes Bay of Bengal very uh, favorable place to form cyclone. And the terrain is very flat, as I mentioned, and population density also high, which actually made a devastating impact. And over the last, since 1991, we see the sea surface temperature is warming and it's increasing at a rate of 0.11 degree centigrade per decade. So, as you know, the global warming so far we have experienced 1 degree centigrade warmer than pre-industrial period, and 90% heat is absorbed by the ocean. So, all this make it is a more favorable condition to form cyclone in the Bay of Bengal. Now I am going to have a look at the other natural disaster that we've actually experienced in the Bay of Bengal. In monsoon season from June, July, we see a prolonged flooding in Bangladesh. And you can see that huge amount of rainfall occur Himalayas, foothill, Meghalaya basin, Assam, and also Nepal. And these water actually coming through Bay of through Brahmaputra and Tista River. And this is Bangladesh is actually a delta of three big rivers. This is Brahmaputra River, this is Ganges, and this is Meghna River. And this huge amount of water actually come Brahmaputra, Tista, and Meghna Basin. But this year we did not see flooding in Ganges Basin in Bangladesh, but Bihar also flooded in India, as you can see. So this whole flooding was one third of the country was underwater, and it was more than 40 days. It was a prolonged flood. You see, this is a graph where we show the number of days above danger level flood, monsoon flood was. In 1998, it was 63 days when the flood water above the danger level. This year, the 40 and plus days actually flood water above the danger level. So after 1998, this is the prolonged flooding. We also see flooding last year. This is the height above the danger level. In 8088, we have a very long peak flood which occurred. You can see from here 20.61 meter above danger, above means PWD data. But after that, all the flood was peak height was less than 1988 flood. In up to 2016, you can see from 2016 the peak height was 20.71, which was above the 1988 flood. But after that, the height of the flood is increasing. 2017 it was 20.84. 2019 it was 21.16, and this year peak was 20.78. You can see there is a trend of increasing flood peak height. We also see a trend of increasing duration. So all this make flood risk management is challenging for the country. You can see the danger level, water level above danger level, and this from 1988, as I mentioned, 20.6 to 20. 1.16 last year. This was somewhere here 20.78. So this increasing height actually make flood management more challenging because of many factors, not only climate change but also land and water use and intervention actually make the flood risks more and Bangladesh become more flood vulnerable. And this is the map in the right side. You can see the different kinds of flood occur in Bangladesh. In upper part of the basin, we see monsoon or river and flood. In northeast part of the country, we can see the pre-monsoon flash flood. In this most of the towns, Bangladesh is now experiencing urban flood because of huge urbanization and also the population growth, and also runoff is increasing, wetland is reduced. So all this makes urban flooding more frequent in recent times. We can also see the tidal and storm surge that I'm going to show that this uh, project is will show cyclone inundation mapping of different cyclones that occur in the past. So, and there is also flash flood in this region, is a southeast region, which is hilly region. So even if a small country, we can see many different types of flood occur in this country. And as I mentioned that from 2016 to 19, we have a number of natural disasters. We have heat wave in 2016, flash flood, and lightning is a new kind of disaster which increasing number of deaths. Actually, this is the number one death. This disaster actually make more fatality than cyclone and flooding recent time. And this could be a number one disaster if you consider the people died in a disaster. And in 2017, in 2 days, 28 to 31 May, 135 people died in Cyclone Mora, and when it is landfall, and 13 June, one single day, 168 people died in landslide. So the landslide is a new kind of disaster which a government declared as a natural disaster from 2016. It was in the past, but due to the increase of thunderstorms and also the exposure, this disaster actually killing more people now than cyclone and flood. As I mentioned that we also see monsoon flood almost every year of last 5 years. We see a couple of cyclones that Cyclone Fani, Roanu, I already mentioned. Why it is more severe recent time? As you know that global CO2 emission and temperature is increasing because of industrialization. And the projection is that in future there will be more increase of temperature. It could be more 3 to 5 degrees in the future if you emit CO2 like the way we are doing. If you follow the business as usual path, we'll be reaching very high temperature, which could be go up to even 12 degree in extreme cases. So we also see the reduction of the sea ice and projection of sea level rise. The business as usual scenario, it goes up to 1 meter sea level rise, and which will be very scary for a country like Bangladesh, which is very flat. As you know, this is a small country, but it has observed many different kind of natural disaster, and as we see, and we can expect it that will change under global warming. Several studies shows that river and flood will be more intense and frequent, drought will be more frequent and severe, salinity will continue to increase due to sea level rise, and also cyclone storm surge will inundate more area. Cyclone of category 4, 5 will be more intense and more frequent in the future. We also going to see the more urban frequent flood and flash flood and heat wave will be polar. So why this is happened? Because Bangladesh actually has lots of exposure in terms of population. Not only Bangladesh, South Asia exposure to tropical cyclone is high compared to North America or Central Africa or Europe. So that's why this the risk is more in South Asian country, particularly Bangladesh, which is a developing country. And under this Oasis platform for climate and catastrophic risk assessment in Asia project, BUET is a partner where Met Office Headley Center will simulate high resolution storm using storm modeling. They already simulated a number of cyclone occurred in the past, also the probabilistic cyclone in the future using 4 kilometer resolution model. BUET already simulated a storm surge inundation modeling using open source Dell 3D model. I will show just soon. And then also we have developed a depth damage function to transfer the inundation into the damage. And Postdom Institute they conducted research on flood and rainfall estimates. They also working on the capacity building training and climate data, and IUCN actually working on coastal vulnerability assessment and transferring these to the major stakeholder and policymakers. Under this project, we have assessed around 12 cyclones that occur in recent past since 1991. These are the list of the cyclones that I already mentioned. So we see the a number of cyclones that occur in the past has been pre-processed using historic catalog of tropical cyclone. There are a number of steps. Storm track, first we have to find the track, and then rebuilding pre-processing of the cyclones that and correcting and recalibrate and downscale. So this process is done in Met Office Headley Center. And you can see the ensemble simulation of each cyclone. There are 9 ensemble members, and it is for cyclone Roanu. To ensemble member give you the probabilistic path of the cyclone and give the amount of pressure and wind speed that could have occurred based on the track that already we have downloaded. And we also simulate this cyclone using weather research forecasting model WORF at BUET. This is another model which is weather simulator, which is a lamped area model and which is also downscale using from the GFS boundary condition. And it used all over the world for NWP systems, and it also simulated at BUET. So this is a comparison of wind speed with time. A cyclone start from here, it's going to develop. It's a 10-meter wind speed, and you can see that it goes and it landfalls here, and then it disappears. And this is mean sea level pressure. You can see it forms. This is for cyclone Roanu, and it comes to the Chittagong area, and then after that it landfalls here in 2016, and then May 21st, and then it goes and disappears. So this pressure and wind actually used in to derive our coastal model, which is Del 3D, which is a three-dimensional model. But for this purpose, we use two-dimensional system. And this is a we developed a mesh for the area, and this is our bathymetry, and this is used using a Dell 3D dashboard model. We updated bathymetry and we simulate. This is, you can see the mesh, rectangular curvilinear grid, and this is the Bay of Bangladesh coast, and these are stations that we compare our results. And these stations from BIWTA and BWDB, two authorities in Bangladesh, which actually observe tidal and river and data respectively. And this is the topography and bathymetry that we collected from defined sources from JEPCO Global Dataset, Bangladesh Water Development Board, Bangladesh Navy, and now also River Survey. So we combine this and make this bathymetry better and refine the mesh accordingly. So the model is now simulating much better. We compare with the observation and we calibrate and validate the model. So this is the different tracks. One is from the JTWC and another from the Headley Center model that I already showed several ensemble models and also the WRF model. So I'll show compare the results. So this is Headley Center ensemble 5, 6, and WRF model and JTWC model. So when the cyclone form, actually this difficult to predict the exact track. That's why this ensemble forecast give a probabilistic path of the possible tracks, and that's why this multi-model ensemble actually used in these purposes. And we can see that the different models gives a similar pattern, but magnitude has some variation. And if you compare to time series plot, you can see that different model capture different way, and some model is better, like Hebley Center is a Cox Bazar area. Ensemble 6 is better than Ensemble 5 if we compare the black torso observation. And this is BIWT observation of black torts, and WRF model is a bit less. And also if we consider a joint typhoon research, that also is slightly less than the peak value. So it's a challenge to capture the track and estimate, but it gives a reasonable accuracy that cyclone and storm surge inundation area. So this is the final runs of the Metaphysics Headley Center model of Ensemble 5 and JTWC track simulation for Cyclone Isla, which occurred in 2009. And after the cyclone inundation simulation, we transferred this inundation into the damage curve using depth damage curve. So we go to the field, we normalize these values with the maximum minus the value minus minimum divided by maximum minus minimum to transfer the depth into a normalized value, and then for each kind of damage, we developed a function with the interview with the local people and field validation. We go to this interact with the group discussion, and these are different kind of how this is a mud house, this is a cyclone shelter, and this is a coastal embankment, which is we call it polder, which protect up to certain height. But sometimes a cyclone can actually breach the polder if it is weak, and it happened in Cyclone Roanu and Cyclone Aila particularly. It actually breached the polder, and it caused a water logging and salinity, a prolonged salinization in the area for a while. And this is the depth damage curve we developed for residential building, and we also developed for road infrastructure, for crop. So after developing this curve, we can generate and if we know the element at risk, we can generate the risks in terms of actually damage, how much damage it could occur from this cyclone. And this is the Oasis Hub environmental data tool services, where we actually upload all these cyclones and their storm surge, wind, and all the data, even depth damage function. So anyone can actually calculate how much damage is expected from cyclone. And this is results are currently transferring. This is the BUET portal, IWFM BUET, storm surge inundation historical tropical cyclone. And this is UK Met Office portal, where you can see all the cyclone net CDF file, also the Oasis native format so that you can do further analysis of risk and assess risk from each cyclone. Under this project, there are also several capacity building training. The last one happened in 19 to 20 on June 2019, where a number of participants, more than 20 participants participate from different government agencies, which show they also able to do the practical exercise to acquire climate data, prepare and manipulate net CDF data, and also they analyze, visualize climate data using Python and also model inherent bias correction. And it was very useful. It was conducted by Postdom Institute of Climate Change and also BUET. And there are also another training that will be in 23rd to 26th November this year, which will be again organized by UK Met Office. That will be under the ARC project, but BUET is going to also host, and the participant of previous training courses can also participate. This will show the sea level rise projection in the future. There are several applications we can apply these tools that is developed under this Oasis loss modeling framework and currently hosted in Oasis Hub. The applications are any cyclone occur. It is possible to simulate to know the possible storm surge inundation depth and inundation pattern. Second application that this tool can be used for adaptation planning, such as building resilient coastal infrastructure or generate scenarios like nature-based solutions like afforestation and then simulate the model. And it also possible to use this model for climate attribution studies and also knows the loss and damage scenario. This model can be applied also the know the future possible inundation considering sea level rise condition. It also possible to use this model in various planning documentation such as Bangladesh Data Plan 2100 or National Adaptation Plan that's going to be updated. And it also possible that this data can be freely available and downloaded from Oasis Hub for research, academic, and any other study or climate negotiation purposes. So this, we hope that this model and tools will be very useful and it's freely available and anyone can use that. And this publication of cyclone and storm charts, we have published a number of papers and also in international peer-reviewed journal, we are going to publish also submit a number of papers on depth damage functions, also how we can use this framework for dissemination of model results. And these are some of the publication floods and possible changes of the flood pattern, attribution of flood in the Ganges, Brahmaputra, and Meghna Basin. And that's all from my side. And thank you very much for listening. And I hope this presentation will be useful. And I like to thank Oasis Risk Modeling Framework and our research partner IUCN and others, Met Office Headley Center for carry on this project with us, for collaborating and making this valuable output for that will be useful for risk assessment in the future. Thank you.